Hello everybody, Mike with Spray Jones coming to you with another exciting video on spray foam insulation. Today we are going to get into the #1 Intel drop on spray foam non-vented roof assemblies. It is an amalgamation of easily 22 years of information that is out there. I covered a lot of these things when I did the 4-part series on non-vented roofs. I went over a lot of the data on our Morrison Hirschfield details and the physics and the ideas of what's going on with the spray foam in real life and in the science, building science perspective. But today we're really going to get into the nerd stuff. So if you are not into looking at the techie info, just click off the video and move on and watch something else of ours that you like. But if you have been waiting, wondering, thinking, arguing, or texting people back online about whether or not closed cell or even low density open cell foam can be put to the underside of a roof deck non-vented, if the roof is going to break off the house, burn up, or melt away or rot away within a short period of time, this is the video for you. So you're just going to have to strap in, get your popcorn, and let's get through it. Now, a public service announcement. Trudeau is making it very difficult. I'm in Canada. Trudeau is making it very difficult for our videos to get out and be seen. So to you, my American friends, who I love so much, I really do. I'm actually really contemplating moving to your wonderful country because I'm so frustrated with our own. You need to click on the subscriptions and the notifications because they're making it more difficult for the algorithms to find non-American content. Since I'm a Canadian YouTube channel, they're trying to cow herd us into Canadians only. Now, I love my Canadian brothers, but hey, there's a lot more of Americans out there, and the American views are what drive the revenue. So click on the bells of notifications and just keep checking back in with us from time to time, because sometimes until this all gets sorted and they punt Trudeau out, we're going to have to deal with this authoritarian stuff until we can hang them by his you-know-whats. All right, so this is an engineering solution that was written. There was a lot of discussion about should spray foam, open, closed cell, non-vented roof assemblies be allowed. And what we're going to do is we're going to scroll through it. I've read the report 3 times already. It's nothing new that I haven't already known or seen. And again, I covered it in the 4-part series, a lot of the core information here, but we're going to see what this has to say. And we're going to get into exactly what can and can't be done. And I'm very, very pleased with it. So here we go. All right. So they are addressing that Alberta has been considering. Alberta, everybody generally knows where Alberta is in Canada. It's just directly over top of Montana and Idaho and all that. So they're considering allowing unvented spray foam roof assemblies in Part 9. Now, Part 9 is our small housing act in Canada. So small commercial buildings and residential commercial buildings. Anything that doesn't need to officially have an architect design it is generally going to be covered by Part 9. Says here that the report explains the performance of wood framed roofs with 2 pound per cubic foot closed cell spray foam insulation, referred to in this report as medium density spray foam insulation, installed to our standard. This is the standard that America needs to start to get in place, that there's a nationalized standard from coast to coast so that you can have consistency in your spray foam installations. They also are going to this report also includes discussion of wood frame roofs, 0.5 pounds per cubic foot, referred to in this report as light density spray polyurethane foam, which conforms again to their standard. The report assumes that all spray foam is installed as per the manufacturer's instructions, yada, yada, yada. Okay, so let's get into scrolling through the map on, here's the different climate zones for the province. It's just talking here about the National Building Code. The latest edition that they were referring to was 2019. IRC code being used down in the United States for my American brothers, 2018. And then they have a number of peer-reviewed, the review of unvented sloped roofs made it into this, the Canadian Conference on Building Science and Technology 2017. This is our bona fide. Then this Jonathan and Straub report on ventilation and vapor control. This is a Building Science Consulting Inc., where they've done these test huts at Waterloo University. A Schumacher 2007 unvented roof assemblies for all clients. And then a Straub and Smith 2010 report, moisture safe, unvented roof and wood roof assemblies. Okay. So they've got the testing criteria, and folks, if it can be done here, it can be done in just about any climate in North America. So let's get on to some interesting stuff here about the report. Otherwise, we're going to be here for 2 days trying to scroll through all of this stuff. All right. So what I found interesting, if an air impermeable insulation combined with a required vapor control, so it's just talking about here why ventilation is needed, right? Moisture related to air leakage and vapor diffusion from the interior moving towards the cold roof sheeting and accumulating, potentially causing roof damage on wood substrate. So it's talking about why is there ventilation? Attic ventilation is required to manage the moisture related, right? Air leakage. I've been saying that from day one. Like you're not venting always a roof just to be dealing with attic temperature. You're dealing with the interior moisture laden air that's inside of the attic assembly with a conventional sheet product and blow in or batted installation. However, if an air impermeable insulation combined with the required vapor control is installed directly to the underside of the roof deck, there is no parallel air leakage paths, then there is limited risk for air leakage or substantial vapor flow, and ventilation below the roof deck is not necessary to provide control within the roof assembly. So there you go. If you are not having an air leakage issue, you are not going to be having a moisture issue, right? Sufficient rigid board or sheet insulation shall be installed directly above the structure roof sheeting. This type of construction is typically associated with commercial buildings. So you know this. You know this from the Home Depot, the Lowe's that you go to. You look down there, that's metal, but you see a metal roof pan, and then you've got the trusses supporting it. Then you've got your built-up rigid exterior insulation. On the outside, there's no ventilation within that assembly. The trusses are entirely kept warm from the exterior insulation. So it said this type of construction is typically associated with commercial buildings where all the roofing insulation is installed to the exterior of the structure. Air-controlled layer is then covered by roofing membrane, correct? This is a safe roof strategy since the structure stays warm, preventing moisture accumulation, and the air control layer applied to the structure stops the warm air from getting into the insulation and reaching colder surfaces. Yes, now let's go to point 2. Where spray polyurethane foam insulation is installed, it shall be applied where? In direct contact with the underside of the structural roof sheathing. So we're giving you a commercial grade system, just not to the exterior. We're giving you the solution to the interior, and therefore you do not need to mess around with a different type of roofing material, meaning you can stick with your conventional shingles. All right, the report then goes on to show us unvented roof assemblies, unvented cathedral assemblies. The thermal control insulation is located within the roof framing, and the ceiling plane follows the plane of the roof, meaning it's vaulted. Unvented cathedralized attics, the thermal control insulation is within the roof deck, and the ceiling plane is horizontal, leaving an attic space that requires some conditioning. So that's going to be your flat ceilings or your mixed coffers or what have you, or semi-slight vaults, maybe like a 112 or a 212 pitch on the interior. Either way, it's not following parallel with the exterior. And then unvented, low-slope, flat roofs, we do this a lot, commonly constructed unvented roof assemblies, although more traditionally it is used in commercial construction, right? Like so a lawyer's office, dentist's office, doctor's office, Rexall drugs, those kinds of things, right? Thermal control and ceiling plane are both essentially horizontal. So the roof line is flat, the ceiling line is flat, less than 25% greater or 2% slope, so that the water will drain from the roof membrane. This slope is usually a result of sloped insulation on a horizontal structure. So they've gone and put built-up roofing, styrofoam sheets on the exterior, establish the slope, and that's how they're going to get the drainage. I have seen it where the trusses are actually canted. They've already established the slope, and then they don't need to cant it with the insulation, right? So it's just showing you your Defford assemblies, right? Vaulted or not, right? There are several architectural, practical, and durability-related advantages to an unvented roof assembly. You bet there are. In many roof designs, the geometrics are complex and making it very difficult to get adequate and effective ventilation of a ventilated roof assembly, potentially resulting in moisture accumulation. We see this all the time. Old-timey roofs, 1920s, 1930s house, 1800s, they never had vents in them. They had brick, they had old siding. You're not going to be able to come in, punch holes into them effectively and get ventilation. Closed cell spray foam should be used. Unvented roof assemblies do not allow the ingress of blowing snow, rain, burning ash, wildfires. In many locations with high forced fire risk, ventilated roof systems are not allowed because of the history of attic fires as a result of embers entering in. We're seeing this with close property line disputes where a rental property or an apartment complex is next to some type of home, and they've had, they have to be so far off the property line or can't be. Therefore, they don't want vented soffits on the property line in the case of one of the buildings becoming on fire and the embers getting into the attic. Moving the thermal control layer to the attic, to the roof sheeting and framing level allows for easier installation of HVAC into the attic because HVAC is inside the thermal enclosure and less concern for leaky ductwork, challenging extreme temperatures. All right. Yes, 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 yes. In Canada, we do not see this that much. We do not see the attic equipment typically in the attic assembly, the HVAC equipment in the attic. America, this is very common. I am currently doing a house right now. We'll be doing a featurette video on it. Slab on grade, 12-foot walls, mixed vault ceiling. And what they're going to be doing is spray foaming the entire roof with us, non-vented, and then all of the ductwork, all of the plumbing, everything that they need to get from one end of the building to the next is going to be going through the roof, through the attic. Right? So that is going to be their mechanical chase to bring everything through because they're slab on grade. I've done this for co-op buildings where they've gone and put a co-op lumberyard, home center. Again, slab on grade, grade beam, backfill. There's no crawl space underneath it. Gone and spray foamed the underside of the roof, non-vented. Had a meeting with the co-op people and they sat there and reviewed it and made a decision for their corporate expansion, and they had like 3 or 4 of these buildings go up, and boom, we spray foamed them all, and then they were able to put the ductwork through. Moving on, there are typically fewer penetrations in the roof deck compared to the ceiling, which often includes lights, speakers, and other wiring, resulting in air leakage through the air barrier. I've seen this with builders that have had complex canister lights in vaulted ceilings where the homeowners wanted it, that combined with bulkheads, and they've just sat there and said, look, closed cell spray foam should be used. We want to have a complete airtight envelope back up and behind in the attic assembly. And then what we do with the drywall and the ceiling and the speakers and the lights and the bulkheads isn't going to affect the envelope. That's a no-brainer. So you're building actually inside. You're using like a suspended ceiling type system to build inside of your warm shell. I don't know why this doesn't make sense to people very quickly. Like, establish your envelope and then just build your grid inside of it, and then you don't have the extensive problems. And then finally, unvented cathedral ceilings provide a greater interior volume, which is architecturally desirable to homeowners, meaning you can make all sorts of chime effective and life change on the inside. Okay, moving along to in the report, page 7 of 17, building science of unvented roofs. They had a concern in here about cold weather climates, moisture accumulation. This is the real crux. This is the intel drop we've been looking for. Are we going to be having an accumulation on the interior side surface of wood-based roof sheeting that's going to break everything down? Well, they tell you right here, what I've been telling you for a long time. I've been telling you that air leakage is your number one problem with moisture, right? 98% of your water problems are air leakage, not vapor diffusion. Well, they say here, air leakage moves. This is moving, just moves 1 to 2 orders of magnitude more moisture in a given time frame. So air moves 1 to 2 orders of magnitude more moisture in a given time frame than vapor diffusion. So it is less common that vapor diffusion causes significant condensation and moisture issues. Eliminate the air leakage, eliminate the moisture problems. One key variable related to moisture durability risk of any enclosure and wall assemblies of a building is the interior relative humidity of the interior space in wintertime, right? Interior relative humidity must be maintained at the recommended level, which in cold climates is 30 to 35%, according to the National Building Code. All right, I agree. Now, we skip down here to where they talk about there are 2 strategies for unvented roofs that minimize the risk of moisture accumulation within the roof assembly. These strategies are as follows. Okay, option 1, install only rigid or semi-rigid insulation on the exterior of the roof structure and provide an air barrier meeting building code requirements. So what that means is you're going to do your built-up roof. You're going to do your multiple layers, pancake layers commercially of exterior rigid insulation. And then you're going to be putting your membrane to the exterior. That's what they're talking about. There's your option. And then as we scroll, they're going to be showing you here. Here's your roof material, your roofing underlay, continuous exterior insulation in here, right? Here's your roof deck. Here's your supporting structure, right? Okay, option two, if that's not practical, and it's not practical, we're here to talk about spray foam, right? Install medium density closed cell or light density open cell against the underside of the roof deck in sufficient quantity to meet the building code, yeah. Correctly installed, however, is an approved vapor barrier in medium density at the required installed thickness. This means with medium density interior moisture, here's the crux of what we want to see. With medium density, interior moisture will not reach the sheathing by either vapor diffusion or air leakage through the field of the spray foam. I'll read it again. This means that medium density spray foam insulation, interior moisture will not reach the sheathing by either vapor diffusion or air leakage through the field of the spray foam. Do you want to know, folks? Talk about all this. Well, if it isn't 2 inches of closed cell foam, it's not a vapor barrier. No, that's not true. You're looking at white paper values for only one sort of thing, and that is the core density with all skin shaved. If you want to actually be a vapor barrier with medium density, in some situations it's under an inch, depending on what substrate you spray it to, like concrete. But if you're going to be spraying it to like OSB, the general rule of thumb is like 1 inch to 1.25 inches. Once you got 1.25 inches of material, you're going to stop the vapor diffusion going through it. That's it. That's all it takes. So it does not allow this wicking effect to go through. Plus, where does condensation develop? It develops on the warm side, right? It's not going to develop on the cold side, exterior. Okay, so now in the report, they're just going to go over a number of details of how they're doing these roof assemblies with a mixed hybrid system, so much rigid outside, so much spray foam on the inside, so much low density, on and on and on. I'm not going to get into all of that. There's just no point. We're here to actually talk about closed cell foam. I think there's something very interesting in this section. When spray foam encapsulates framing, sealing up the framing is not, built-up framing is not required. So I've talked about this in our caulking videos and do you need to air seal? When you have got doubles or triples, you've got a girder truss, you always want to skin over these with either your open cell or your closed cell so that the spray foam has sealed and that air is not going to go between these and create a weak spot of air leakage at the sheeting level, right? So if you are going to have it as it shows here, medium density or closed cell or open cell or closed cell, caulk these seams. Get out your silicone, get out your high quality polyurethane and caulk the assembly so that you're not having air leakage. This is what we do on studs for walls, and this is what we do. I had a guy that had doubled up, sistered up 2x10s for a low slope deck on a structure, and what we ended up doing is we put like 3 inches of closed cell foam frame on a retrofit in between all these, and then every one of those sistered up 2x10s we went and caulked the face of so that the air stopped. Okay, moving on. Literature review. What have they been reviewing? They've got all these extensive reports. Well, here's what we want to see. The high growth thermal analysis from 2010. And if we come right here, here's the sauce. It was found that in climate zone 6 and 7, so this is in Alberta, so the coldest climates, not into the Arctic, not in the Northwest Territories, but climate zone 6 and 7, the full depth, medium density spray foam roof assembly did not show any risk of moisture accumulation in the sheathing with dark asphalt shingles, even with an elevated interior relative humidity for each cardinal orientation. The assembly with 4 inches of medium density and spray fiberglass performed the same. So that's because the 4 inches of medium density is taking up 100% of the work. Just shows you how well 4 inches of closed cell foam is. So there you go, folks. No moisture is making it to the roof deck. None. So I've been saying this for years. You're not having a moisture issue. And folks, apply this to the walls. Apply this to your outside walls. You go and have 3 or 4 inches of closed cell foam to a 2x6 wall. The same physics are going on with moisture drive and air leakage and all of that to the wall assembly. So if you're going to have a wall assembly where you're having damage or you've had damage to the exterior from moisture from the outside, it's going to be an outside exterior issue. 9.5 times out of 10, you're getting water back in behind the siding and it's rotting it out from the outside, right? The better the spray foam job, the harder it's going to be to detect. Moving along, it was found that even under very conservative prediction criteria for climate zones up to 7A, meaning up towards the Arctic, that it was found that an unvented full medium density spray foam application did not result in increased sheathing moisture content with the recommended interior relative humidity level of 30%. With elevated interior relative humidity every year and the coldest weather data available to model, there were some eventual elevated sheathing moisture contents on the north orientation following repeated years of analysis. But under normal situations, you might have a climb up for a little bit, but then that's going to come down as you wick and have things dry out. Right? Even CMHC document titled Arctic Hot Roof Design was published in 2001. I did that in my non-vented, the very first non-vented 4-part series. I showed that 2001 document. We go over it, explaining the benefits of the unvented exterior insulated roof assembly with board foam insulation compared to typical vented attic assemblies, right? All right, let's move on to roof underlays. We're almost wrapping up here. Because of the unvented roof assembly with full depth, medium density is unable to dry sufficiently to the interior. Yes, we know that. It is critical that the wood sheathing not get wet and or remain wet for extended period of time. Yeah, of course. Now, I got to address something here because I've had people that have sat there and said, okay, that's it. We're not using spray foam. We're not using it. No. Can't diagnose the problem. Can't figure anything out. So therefore, we need to let something put up there that's going to allow the water to come through. Freaking bollocks. You're telling me that you need to use inferior materials that are going to allow the water to come through and get into the interior side and wreck your insulation and wreck your drywall and wreck your ceiling. Like, folks, where is your seal going to be? You're going to put one hell of a good seal at the drywall level, like absolutely airtight, watertight, you name it. So then that means the water can come into the attic, fill the attic up with moisture, wreck the insulation, and you didn't see it because you didn't notice it at the sheathing level, like the interior sheathing level. Like, at some point, you got to stop. So you're telling me that you want to have water get through the roof deck, water get through the insulation, water get through the vapor barrier, water get through the drywall. Yeah, that's what we want. Okay, well, I can't think like you. I just can't. Like, you're supposed to be doing the absolute best job that you can, and then if and where there is damage, you're going to have to control and deal with the damage at those exterior levels. And that means that we don't sacrifice using high quality products. Otherwise, every commercial grade BUR system would be outlawed because you've got a water impermeable layer to the exterior that you put in there. If water gets back in behind there, yeah, it can't easily get out, right? All right, so what are we finding here? Roof underlay can't dry to the interior side. Typical shingle and metal roof assemblies manufacturers recommended best practice for roofing underlay should be used. This typically requires self-adhering membranes, ice and water shield in some areas to minimize the risk of ingress ice dams combined with synthetic underlay over the remaining roof assembly. Some manufacturers even recommend self-adhering membrane beneath the whole entire roof assembly. Yeah, make the thing waterproof to the outside. Matt Reisinger's talked about that for exteriors. That your exterior should be 100% waterproof before your siding goes up. Well, what about the roof deck? Why not have the roof deck 100% waterproof before the shingles go on? And then you got the spray foam on the interior side. Spray foam has nothing to do with causing the roof deck to degrade faster. Nothing. It's your insulation. It's your envelope, part of it. Your exterior is very, very, very important. So have a good roofing contractor and have good products on the exterior side. This always becomes the issue with people that want to cheap out. They want the $627,000 house, but they want to show all their friends they got the $900,000 house. So they hired the cheapest people and the cheapest products and the lack of everything and installed it in the cold weather or the rainy weather or whatever. And then they want to go and bitch and moan that they got screwed over and that they've got $100,000 or $200,000 worth of damage. It's like, yeah, well, you didn't get a quality product the first time around. You know, you hired budget people and budget products and you got the budget amount. Now you're paying. You do not get to keep the money, folks. You do not get to keep it. Either pay up front and do it once, cry once, pay once, or cry later when you've got to try and figure out where you're going to find $50,000, $60,000 to pay for damages and everybody's long gone. Okay, so that's my little rant. The traditional building paper or felt paper should not be used in unvented roof assemblies because it tends to break down more quickly and not provide a continuous water layer for the life of the roofing. I find that a little bit interesting. Not that it's wrong, just they're seeing the importance of longevity for the underlay. Okay, let's move on to fire codes. The use of spray foam in an unvented cathedralized roof assembly typically means that spray foam is left exposed to the underside. There are restrictions for accessible spaces within regards to the exposure of spray foam insulation. So in our codes, you can't just be leaving everything wide open. However, the attic or the roof space is considered concealed when the gypsum board is below the attic or roof assembly will provide the required thermal protection, right? So basically, as soon as we go and put sheetrock up, whether it's to cathedralize the attic or to vault the attic, depending on what it is, it's no longer considered open. So it doesn't matter whether we got 4 or 5 feet of space in our code between the gyprock and the spray foam. That space is neither here nor there because it's considered concealed adjacent space. Therefore, no additional steps need to be taken with fireproofing. Now, this is, if you've stayed this long, here we go. This is the most important thing. Vapor permeance of wood framing. And unvented roof assemblies where the medium density spray foam fills the cavities between the structure, the interior of the structure is left exposed. It is clear that the medium density spray foam has sufficient vapor control to meet the vapor barrier requirements, but there is some uncertainty regarding the vapor permeance of the rafters. So you get what's going on here. You got your rafters or your studs, and you got spray foam in between them, closed cell, medium density, whatever. But let's just concentrate on closed cell. Do you have vapor protection out of the studs themselves? Common question, right? What is the vapor permeance of the rafters? As with most hygroscopic materials, the vapor permeance of wood varies depending on the surrounding relative humidity. So they went and tested everything here with Exova, which is third party. And what did they find? Right here, 2x4, 2x4, 2x6. We are under 1 perm with 2x4 and 2x6. So moving down to the results, this means right here, this means that based on test results and available literature, the framing does meet the vapor barrier requirements in unvented roof assemblies with the full R value installed of medium density foam. The vapor permeance of OSB is found in the, get this, web of TJI joists would also meet the vapor permeance requirements as per OSB vapor permeance values and the ASHRAE manual. So there you go, folks. The studs and the engineered wood products are going to meet your vapor diffusion. Conclusions. It's clear that unvented sloped and low sloped roof assemblies will safely function in the province of Alberta, and 3 prescriptive types of roof assemblies should be allowed in Part 9 construction as well, will satisfy the requirements of blah, 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 blah. So when you have sloped or low sloped assemblies, the required R value installed on the interior of the structure as required by rigid or semi-rigid as continuous and effective air barrier is required on the roofs at the interior of the insulation to prevent moisture movement by air leakage and vapor diffusion. Low sloped roofs assemblies with the entire required R value to meet the effective R value requirements installed by as spray foam directly to the underside of the roof sheathing. Or medium density includes vapor control, no additional vapor barriers required. Low density does require something in cold weather climates. A combination of exterior and interior semi-rigid, and that tells you exactly what you need to see and hear. That the interior wintertime relative humidity is controlled. and that it is important. All other enclosure assemblies, not just roofs, and the control of condensation within the interior of windows. So they must have their interior space controlled, but they've already done the tests that the spray foam isn't going to build up and accumulate moisture accumulation to the underside of the roof deck. So there you have it. And then it's been signed off on and sealed, and this went out. This report was done March 4th, 2022. And this is being used in other jurisdictions now for approvals, because once precedence is set in one area, you can generally use it to establish things in a second. So, long video, not for everybody, but for those of you that stayed, it's because you're dedicated and interested in watching the spray foam insulation tech reports and knowing that the foam can be applied to the deck. The wood studs are going to work in conjunction with the spray foam permeance, and that moisture levels are not going to be reaching the underside of the roof deck. This ends it. It's clear cut. It's definitive. It is the sauce. It is the data. There it is. So all the criers and whiners can fade off into the sunset. So click on the video for like and subscribe. Share it with somebody that needs to see it, and we'll catch you on future videos not this long. Thanks.